Have you ever been in like a lecture or trying to read something really dense and you just feel passive, like the information is just sort of washing over you, not really sinking in? It happens all the time, that feeling.
Oh, absolutely. That disconnect is super common.
Well, today we're doing a deep dive into something that might just change how we think about that. It's called the Taxshila Taxonomy, and the claim is pretty big that it actually maps how our brains naturally learn.
Mapping the brain's process. Interesting.
Yeah, and we're basing this on some recent research excerpts. Taxshila Taxonomy, Mapping the Brain of Learning by Shivanarayan Taxshila Page. It gives us a kind of shortcut to understanding what seems like a really radical shift in educational thinking.
Okay, so what's the core problem they're trying to solve?
Well, the research basically points out that traditional ways of thinking about learning, like Bloom's taxonomy, which many people know.
Right, the recall, understand, apply hierarchy.
Exactly. They focus a lot on those cognitive skills, often tested verbally or, abstractly. But here's the thing. They often miss crucial brain functions, like motor skills, spatial awareness, and executive functions, things that control planning and attention.
Ah, so not just the thinking part, but the doing and organizing parts too.
Precisely. And the research argues these aren't just extras, they're vital for real learning, but they often get left out of that traditional sort of teacher-led model.
Okay, I see where this is going. So the Taxshila taxonomy comes in as an alternative.
Exactly. It's apparently grounded in something called Taxshila neuroscience and this emerging field, learnography.
Learnography, okay?
And what makes it revolutionary, or so they claim, is that it aims for a much more direct knowledge transfer from the material right into your brain. And the key is using active motor engagement and letting the learner direct their own practice more. It's less about what you're taught and much more about how your brain is actually wired to grab onto information.
Well, that explicit link to neuroscience is definitely fascinating. Moving beyond just abstract ideas about thinking to actually understanding learning as like a biological thing happening in the brain.
Yeah, designing learning so it fits how our brains work naturally.
Right. Aligning the process with the hardware, so to speak.
So let's unpack that difference then. Taxshila versus Bloom's. You said Bloom's is more cognitive classification.
Yeah, it's largely assessed through, explaining concepts, answering questions, verbal stuff, mostly.
But Taxshila maps learning to specific brain systems. You mentioned motor science, spatial temporal mapping, executive modulation. Can you break those down a bit?
Sure. So the core idea is that learning isn't just mental heavy lifting, it's physical too, in a way. Motor science is basically learning through doing. Like, think about learning an instrument or a sport. You don't just read a manual. Your body learns the movements. That physical action encodes the knowledge.
Okay, makes sense. Like muscle memory, but for broader learning.
Sort of, yeah. And spatial temporal mapping. That's about how your brain organizes things in space and time. It could be understanding the sequence of steps in a procedure or how different concepts fit together visually, like a mind map almost, but happening internally.
Right, seeing the connections, the bigger picture.
Exactly. And then executive modulation, that's like the brain's project manager. It handles planning, shifting attention, solving unexpected problems, managing your own learning process. Self-regulation.
Got it. So Taxshila focuses on activating these systems.
Yes. The focus shifts dramatically away from just passively receiving info towards actively constructing knowledge in your brain. They call it brainpage construction and motor engaged learning.
Brain page construction, I like that. Like you're building a page in your own mental textbook.
Kind of.
Yeah.
And the research showed this pays off. Learners using the Taxshila approach, they apparently had higher creative output and could apply knowledge across different areas much better than those using Bloom's. And they attribute that directly to this brain-based, task-focused method. You're not just thinking about it, you're building it neurologically.
Okay, that's a huge shift. And it seems really practical when you look at their framework. It's not just theory, right? They have these 6 Taxshila levels.
That's right, levels 0 through 5. Level 0 is basically non-functional, like no real engagement. And it progresses up to level 5, which represents someone at the level of, say, a research scholar, deep expertise, autonomy.
And these levels track growth.
Yeah, they're designed to mirror how a learner gains autonomy, how their neural networks develop, and how they handle increasingly complex tasks. It gives you a clear roadmap. You can see where someone is, not just in terms of what they know, but their capacity to learn and apply. It's measuring intellectual maturity, in a sense.
Okay, so the levels are like the vertical axis of progress. But there's a horizontal aspect too, these 7 dimensions of knowledge transfer, KT dimensions.
Exactly. If the levels show depth, the dimensions show breadth, and the different ways knowledge is handled. Each dimension represents a distinct cognitive motor function that contributes to building that brain page we mentioned. It's about how you encode, organize, and use knowledge.
Can you give an example or two? What are these dimensions like?
Sure. The research mentions things like the definition spectrum, basically, how well and how broadly you can explain a concept, not just repeating a definition, but exploring its nuances. Then there's block solver, which is about your skill in breaking down complex problems and tackling them piece by piece.
Ah, like logical problem solving in action.
Right. Another one is task formator, your ability to actually design and carry out a task based on what you've learned, turning knowledge into action.
So each dimension is an active skill, not just passive knowledge.
Precisely. And when you put the 6 levels together with these 7 dimensions, you get this thing they call the 6x7 learnographic matrix.
The matrix sounds complex, but also powerful.
It is. And the key thing is, it's not static, it's dynamic. It shows where a learner is right now, which means you can tailor support, interventions, next steps, all based on their actual performance profile, not just a generic test score.
It's like a personalized GPS for learning. That's really neat.
That's a good way to put it. And this whole idea really hinges on the brain page concept and making learning active. It's like thinking of your brain less like a storage unit and more like a workshop. You're actively building mental model.
Building, tinkering, connecting.
Exactly.
Yeah.
And the research talks about brain page classrooms where that's happening constantly. Hands-on stuff, students helping each other figure things out, peer moderation, and learning driven by tasks.
And that's where learnography fits in, this focus on direct transfer.
Yes. It's all grounded in that principle,
Right.
making the transfer of knowledge tangible, active.
And it comes back to that key idea. It's about doing, not just knowing.
Absolutely. The study emphasized assessment through performance on tasks, what they call brain page output, and also peer feedback, like in their miniature school system idea.
Miniature school system. What's that?
It seems to be a setup where students take on roles like teaching peers, moderating discussions, even doing small research tasks, mimicking a real knowledge-sharing environment.
Interesting. So assessment is embedded in the activity itself.
Right. And they found this fosters much more authentic learning. You're not just memorizing for a test. You're applying, transferring knowledge to new situations, even creating new insights.
It moves way beyond rote learning.
Way beyond. It's about building a flexible, usable understanding, like the difference between memorizing recipe steps and actually being able to cook, adapt, improvise in the kitchen.
That makes perfect sense. And what about the results? Did they find this actually works better in practice?
Well, according to the research excerpts, yes. A major finding was about retention. Learners involved in these motor-driven brain page activities, they apparently showed significantly better long-term retention and deeper understanding compared to students in more traditional verbal-based classrooms.
So engaging the body helps the brain hold on to information better. It feels intuitive, actually.
It does align with a lot of neuroscience, yeah. If you actively construct the knowledge, it seems to stick better.
And what does this mean for teachers? Their role must change quite a bit.
Oh, completely. The model positions educators less as lecturers and more as maybe learning architects or knowledge guides. Their job becomes guiding students through that self-directed brain page making, helping them design tasks, giving feedback on performance. It's much more coaching than telling.
Less sage on the stage, more guide on the side, as they say.
Exactly that. Cultivating the learning environment rather than just delivering content.
And the classroom dynamic itself changes, too, with that miniature school system idea.
Right. It encourages cooperation, students leading their own learning, taking responsibility, learners acting as small teachers, moderators, researchers. It sounds like it mirrors how knowledge work happens in the real world in teams and communities.
So if you pull all these threads together, the brain alignment, the active learning, the changed roles, what's the big picture implication here for education's future?
Well, it certainly raises some big questions, doesn't it? Like, how could this kind of brain-friendly approach potentially unlock potential in learners that traditional methods maybe haven't reached? Could it make high-level learning more accessible, more democratic, by tapping into these fundamental cognitive motor processes we all share?
That's a powerful thought. So just to wrap things up for everyone listening, the core idea here is that the Taxshila Taxonomy presents this biologically grounded alternative. It bridges neuroscience and education, aiming for direct knowledge transfer, boosting creativity, and supporting, well, genuine lifelong learning skills.
It really shifts the focus from just what is learned to how the brain most effectively learns it.
And for you, the listener, the takeaway isn't just academic. This framework offers a kind of roadmap based on how your brain works for your own learning journey, a way to get truly well-informed, deeply and efficiently.
By engaging more actively, more physically, more aligned with your natural systems.
Right. Which leaves us with a final thought to chew on. If learning works best when it aligns with our brain's natural design, what other parts of our lives, our work, our experiences, could be transformed if we started designing them to be truly brain-aligned?
Hmm. That's something to think about, applying these principles more broadly.
Right.